We are going to talk about logarithmic derivatives. See, it wasn't for nothing. Braden watched the logarithm video, and he's going to be good. Okay. All right. First of all, though, we need to remember our properties of logarithms because those are going to help us when we're actually doing the differentiation of logarithmic equations. That's a lot of syllables I had to spout out there. Okay? Do you remember what happens if we are multiplying inside of our logarithm? How could we rewrite it? The base stays the same. I said base, so I was going to write base. But we add our two logarithms together since there's multiplication inside. I promise this will be of benefit to you. What about when we are dividing inside? If we were to expand this out into two logarithms, what would they be separated with? Subtraction. So we have log base b of a minus log base b of c. And last but not least, if we have a power inside of our logarithm, what can we do with that power? Multiply, I guess I should go this way. Multiply it out in front. This can be r times log base b of a. Okay. If we have to take the derivative of a logarithm, and we have something super complicated inside to where our chain rule is going to be gross, we can use these properties of logarithms to expand it out and take the derivative a much nicer way. Okay. So what I'm going to have you do very quickly is work together at your table. Take 60 seconds and expand this logarithmic expression for me. Square root means what power? Good. Julia, what do we got?
1/2 log base 5 x plus 1 minus log base 5 x.
Do you agree with Julia? Good, because she's right. Okay. Do you think you need one more practice before we get to the derivatives? Give me a yes or a no. Do you want one more to practice? Good either way. Here we go. The derivative. Let me give you the screen shade. The derivative of the natural log. Are you ready for it? This is a rule that you need to remember. Like maybe for a rule quiz, that could happen at any time. 1 over x. Ta-da! That's it. Yeah. How often am I going to give you the natural log of x? Like not very often, okay? So let's just talk about the chain rule here. What if I had the derivative of the natural log with something inside? Okay, so just write it down. I have the natural log of f of x. Okay. The derivative of natural log of x is 1 over x. So the derivative of the natural log of f of x is 1 over f of x. And then times the derivative of the inside, because we do have a composition, we would have to apply the chain rule. Okay. You could put that in the numerator if you'd like, yes. No, it cannot be in the denominator. So this is like over 1. I'm just not writing it as over 1. Like that? Where that is an actual prime that you can tell is a prime? Yes, if you want to write it like that, that is more than okay. Okay? Means the same thing. Okay? Okay? But our natural log derivative is just 1 over what's inside. And then apply the chain rule if necessary. Okay? Should we practice? Yes. What did you say? It's Canadian. Okay. So if y equals the natural log of 2x, then dy dx is going to be, well, it's a natural log, so we're going to take 1 over what's inside. Is that it? Times 2. So, right, we could simplify it to 1 over x. That's it. Okay? Here's our next one.
Will that just mean that anytime it's just like a coefficient in x, it's just going to be 1 over x every time?
So if y is the natural log of x squared plus 1, then our derivative, write down what you think it is. Some of you already have. But if you have it. Alex, how do we do it?
Do 1 over x squared plus 1.
Okay. Times.
Times 1.
So we have a composition.
Oh, shoot. Times 2x.
Times 2x. Very good. And if you write this as 2x over x squared plus 1, I'm happy. If you write it like this, I'm happy. Okay? Yeah. I mean, we can rewrite this as 2x. Yeah, then there's nothing else I want you to do. Okay? Unless I ask you for a tangent line equation and you have to plug something in, but that's it. Okay? So let's go ahead and just make sure that we can remember our other rules while working with the natural log. We did function. We did function.
Would you like step down for row? Bravo Jacks.
Is that what we need to do each morning so you can get all your energy out?
No.
Or absolute value ones? Okay, what do we have? We have a product, x times natural log of x. So when we take our derivative, we better use the product rule for our product. Okay? And if it helps. Okay? Some of you may benefit from writing out f prime times g plus f times g prime. If you need to write that out, I have no problem if you need just kind of that visual reminder. Okay? What is the derivative of the first function? 1 times our second function plus our first function times, what's the derivative of our second function? 1 over x. So you could leave it like that, but we could also write that the natural log of x plus 1 is our derivative. Okay. At your group, come up with this derivative for me. Compare answers. If you don't do it together, at least compare your answers. Yeah. All right. Everyone back up here. Xander, what do we do?
You have to do
How about you just tell me what it is instead of explain? Just tell me what it is.
3 times the natural log of x times 1 over x. Yeah, natural log
With
of
that?
x.
Okay. All right, so we did the power rule. Don't forget to keep your power subtracted by 1. All right, so we did the power rule. 3 natural log of x, decrease the power to get the square, and then the derivative of the inside is 1 over x. Okay, so you guys are like, yeah, this is like nothing, right? You're feeling good? Okay. What if I gave you something like this? No. I've given you very simple derivatives so far, but this one, you look at it and you think, yikes, this is complicated. Okay, we have logarithmic properties to where we technically have 2 different ways we could take this derivative. We could keep it like it is and use the chain rule with a quotient inside of it. Or we could expand it using properties. We could rewrite y to be 1/3 natural log of x minus 1 minus 1/3 natural log of x plus 1. How do you feel about those 2 individual derivatives?
Pretty cool.
They look that? This is what I see. I don't have to do the quotient rule. And really, I don't have to do the chain rule. Yeah. All we have to do is take our derivative. So we have 1/3 times the natural log of x minus 1. That derivative is 1 over x minus 1. And the derivative of the inside is 1. So I'm not going to write it. Minus 1/3 times the derivative of natural log of x plus 1. is 1 over x plus 1 times chain rule 1, but we don't need to write it. Was that complicated?
Not really.
You're done. You don't have to like condense it back together. We can leave that just like that. Okay? If we would not have expanded it, we probably would have used this whole white space and another one. Well, probably just this whole white space right here. And I would have to write really small to squish it all together. Do you want to see what that would be?
Yes.
No.
Don't write it down. Can you do that for me? Don't write it down. Don't write it down. If we didn't expand it, y prime would be 1 over the cubed root of x minus 1 over x plus 1 times chain rule 1/3 times the inside raised to the negative 2/3 power times chain rule, the derivative of the inside, 1 times x plus 1 minus x minus 1 times 1 all over x plus 1, the quantity squared. That would be the derivative if we didn't expand. So I will ask again, which one is more simple? Expanding or not expanding? Expanding. Okay. Here's your other question. Okay. You're welcome to do this, but expanding makes our life a lot more simple. Okay? Right-handed? Yeah. He's like, oh, I'm gonna do this. Okay? All right. Go ahead and keep your pencils down, okay? Because I don't want you to write this down either. Do you remember back in pre-calculus when we did the change of base formula? So if you had log base a of x, in your calculator you would type in log of x divided by log of a. Okay? You may not remember that, but that is what you did until you found a little shortcut in your calculator, which is fine. But this is the change of base formula. Okay? Now, I am going to show you where this derivative comes from. You don't need to know how to get here. I just kind of want to prove to you where we get this from. Okay? So you're not writing this down because it doesn't really matter to you. Log base a of x is what we want to figure out what the derivative is. Well, we just said that our change of base formula is natural log of x over natural log of a. So if we take that derivative with respect to x, we have a quotient, correct? Okay? So in a quotient rule, we take the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Natural log of a, that's just a number, because a is a number. So that would just be 0 for our derivative. Okay? Over the natural log of a, the quantity squared. Okay? Well, we have the natural log of x minus, or times 1 over x times the natural log of a minus 0 all over the natural log of a squared. So one of those will cancel here. And we simplify this to 1 over x natural log of a. Okay? I will never ask you to reproduce that. Okay? So don't worry about that. What I do need you to understand, though, is that the derivative of log base a of x would be 1 over x times the natural log of a. Go ahead and write it down, and I'll kind of talk through what I want you to remember about this. So we're not worrying about this up here anymore. I just showed you where it came from. You can forget it from your mind. Consider it forgotten. Okay. So if you have the natural log of x, we can just do 1 over x for our derivative. But if we have a base other than e, The derivative is similar, yes? Do we still have 1 over x? Additionally, we just need the natural log of whatever that base is. Okay? So 1 over x, natural log of the base. Okay? All that changes is this right here. Okay? If there is some sort of a chain rule, please don't forget about the chain rule. So if it's f of x inside instead of x, then we would have to multiply by the derivative of the inside. Okay? So let's practice that rule. Log base 3 of x is our first equation. So the derivative of log base 3 of x, it's a logarithm, so we're going to do the 1 over x, but since it's base 3, we need natural log of 3 in the denominator also. How about log base 3 of 3x? Okay. So when we find the derivative, since it is a logarithm, we're going to take 1 over what's inside. But since it's log of a different base, we need the natural log of that base with the denominator. And what's inside of our logarithm? 3x. What is the derivative of 3x? So we'd have to multiply by the 3. Okay, don't forget about the chain rule after you do all of your rule work. Your turn. Not the natural log. Log of cosine of x. There's no base. Base 10, common base 10. We don't write 10, you assume 10 if nothing is there. All right, Kinley, walk us through this.
So you basically just do 1 over and then do the natural log of 10 times the cosine of x, and then multiply that by the negative sign of x.
Okay, good. So we have 1 over what's inside, and since it's not natural log, we have the natural log of the base with it. And then since we do have a composition, we have to apply the chain rule. The derivative of cosine is negative sign. Yes.
You have to write L and 10 and then you just write
It has to be L and 10. It has to be the natural log of whatever that base is, unless it's E, and natural log of E is 1, which is why we don't have to write it. All right. Wait, time out. Oh, yeah, let's do this one. Perfect. Okay, here again we have log base 10. When we take our derivative of any logarithm under the sun, any logarithm, we're going to take 1 over what's inside. But since it's not base E, we have to also put natural log of the base. And since it's a composition, we better multiply by the derivative of the inside to apply the chain rule. Okay. So no matter what logarithm it is, our derivative has 1 over what's inside. It's just whether there's a logarithm with it or not. Okay? And those are the rules you're going to have to practice. Okay? Now, some of you might think, well, how often do we have logarithms? Like, is this really going to pop up that often? You don't have to necessarily have a logarithm in your equation to use a logarithmic derivative. That sounds strange, right? Okay. I want you to go ahead and write down logarithmic differentiation, like write that down so you have it to refer to in your notes, and then write down this equation right here. Are you cringing at that equation? A little bit? Yep, me too. We have a quotient, where inside of our quotient we would have chain rules to take care of. And there is nothing wrong with leaving your equation like this and taking the explicit derivative and using the quotient rule with your chain rules. However, now that we know a little bit about logarithmic derivatives, we could use them to help us. Okay? So let's say I don't want to do this derivative with a quotient rule and a chain rule. Okay? What if we took the natural log of both sides? Is that allowed, first of all? Okay? If I do something to one side, as long as I do it to the other side, we should be okay. Right? So we can take the natural log of both sides. Now, what would be the benefit to that? Now we can expand out the right side to where we can write the natural log of y equals 2 natural log of x minus 2 minus 1/2 natural log of x squared plus 1. Now, we did start out with an explicit function, y equals something in terms of x. Well, now that we've done the natural log to both sides, we don't have that y equals anymore. So we are working with an implicit function at this point. That's okay. We know how to do derivatives implicitly, okay, which is why this section comes after what we just did. Okay. So let's take the derivative at this point. The natural log of y, its derivative would be 1 over y dy dx. Derivative of y with respect to x. We always got to remember that chain rule. Okay. Then we have 2 times the derivative of the natural log of x minus 2. So just 1 over x minus 2. Okay. Minus 1/2 times the derivative of natural log of x squared plus 1. Well, we have 1 over what's inside. And then we would have our chain rule. Okay. Now, what would our last step be? Okay, we want to solve for dy dx, so we would need to multiply the y to the other side. Okay. So, dy dx equals the quantity. I'm just going to go ahead and write this as 2 over x minus 2. Since we have to rewrite it, I'm going to go ahead and just make it look a little bit more pretty. I'm going to write this as x over x squared plus 1. All right, because technically the 2's would cancel. And then we're multiplying by y. We multiply that y to the other side. Now, technically, this is not a wrong answer. However, what sort of equation did we start out with? Implicit or explicit? It started out explicit. Y equals something in terms of x. If our equation starts out explicit, then your derivative should match. So, right now our derivative is in terms of x and y. It's implicit. That's an easy fix. Because do we know what y equals? Yeah, we know that y is x minus 2 the quantity squared over the square root of x squared plus 1. So we can just replace y with what we already know that is. And then we have our beautiful derivative. What? You may not be so. You may be fine with coming up here and doing the quotient rule with all of the chain rules inside of it, and that's fine. Okay? Some of you may not see this as a shorter way of doing it. Okay? But is it nice to have options? It's nice to have options, especially as we're getting closer to Unit 3. When we start to set something like that equal to 0 versus a big monster fraction with lots of radicals inside of it, okay, we may want to make some decisions about what's going to be better for us. Okay? You guys realize we still have 3 minutes left, right? So when I'm talking and you're packing up, this is 3rd hour, isn't it? So 51, right? Am I not wrong? Okay. Like when you're packing up and I'm talking, like that really bothers me. Okay, just stay focused. Okay. So in your homework, I am going to ask you to take a derivative by logarithmic differentiation. I'm going to ask you to do this strategy so you can practice it. Okay. There will be a question on your quiz Monday. Do this derivative with logarithmic differentiation. Okay. But once we get past chapter 2, okay, now that we've built our skills, you can kind of decide, is that a time saver for me or not? Okay, next. Okay. Now, your homework tonight, I don't know if you've looked at your gold sheet or not, but it comes from 2 different pages. One of the pages is all about natural logs, and one of the pages is all about log base something else. And they're coming from chapter 5. So don't freak out when you're like way far ahead of where you were last night. We jumped a little bit into chapter 5 to grab our logarithmic derivatives, and then tomorrow our exponential derivatives. Okay? If you do not practice, will you remember the rules? No, you gotta practice. Okay? Now you can pass.